All right, let's jump in. I want you to picture the year 1997. The internet is starting to boom, but our entire digital life, pretty much everything, is stuck inside these beige computer boxes. All that amazing information, all that potential, was completely locked away behind a screen.
And this contrast, right here, gets to the absolute heart of a problem the two MIT Media Lab researchers, Hiroshi Ishii and Brig Omer, were obsessed with solving. They saw us becoming this person on the left, isolated in this sterile digital cube, totally cut off from the messy, collaborative and, well, real world on the right.
As they so perfectly put it, it felt like we were becoming citizens of two totally different worlds. There was the physical world, the world of atoms, and then there was cyberspace, the world of bits. And we were just constantly bouncing back and forth between these two separate, really disjointed spaces.
Now, to really get why their solution was so brilliant, we have to understand the world they were pushing back against. At the time, pretty much all of computer interaction was dominated by the graphical user interface, the GUI. Yeah, that familiar world of windows, icons, and mouse clicks we all still live in today.
What's really cool is that the researchers got their inspiration by looking backward at these beautiful, old scientific instruments. I mean, think about something like an astrolabe or a sundial. They weren't just tools. They were physical things you could hold and feel and manipulate. And Ishii and Ulmer believed we'd lost that deep, tactile connection to information.
And this really is the core of it. We humans have spent thousands of years developing these incredible skills for dealing with the physical world, right? We can sort things, stack them, arrange them with amazing dexterity. But the computer interfaces of the day just ignored all of that, flattening that richness into just pointing, clicking, and typing.
So, in this absolutely groundbreaking paper from 1997, they laid out this revolutionary new vision to finally bridge that gap between the physical and the digital.
They started with a really powerful, almost deceptively simple question. What if data wasn't just pixels on a screen? What if you could actually hold it in your hand, turn it over, and really feel it? This was the lightning in a bottle idea behind their concept: tangible bits. And this idea led them to define what they called tangible user interfaces, or TUIs. The big idea here was to just stop trying to cram our big, messy world onto a tiny desktop screen. Instead, why not flip it? Why not make the world itself the interface?
They broke this whole vision down into three key concepts. First, making everyday surfaces like tables and walls interactive. Second, finding a way to directly connect physical objects to digital information, to couple bits and atoms. And third, using these background cues like light and sound to communicate data without us having to stare at it. Let's see how they actually made this stuff happen.
Okay, now let's look at the actual prototypes they built back in the 90s, because this is where all that theory becomes really exciting and, well, tangible.
This is the metaDESK. This was their big attempt to take the ideas we know from our computers, things like windows and icons, and pull them out of the screen and into the real world, right there on your desk. So instead of a digital icon on a screen, you could use a physical icon, what they brilliantly called a phicon. In this case, a little model of an MIT building is used to call up a map. And that screen on an arm? That's the active lens. It acted like a movable physical window that gave you a 3D peek into that digital world.
What's so cool about this is that they were literally inventing a whole new language, a new vocabulary. A window on your screen becomes a physical lens you hold. A digital icon becomes a graspable phicon. They were translating the language of the computer into the language of the physical world.
Okay, but what about all the information you don't need screaming for your attention all the time? How can data just exist in the periphery? Kind of like the sound of traffic or the weather outside your window.
Well, that was the whole point of the ambient room. In here, the digital information wasn't on a screen at all. It was expressed as ambient media, these subtle changes in light or sound or movement in the room around you.
Just imagine the scenario they came up with. Web traffic for a new toy is represented by the sound of rain. A nice, steady patter means traffic is good. But if it suddenly goes silent, that silence moves from the background of your awareness right to the foreground. It grabs your attention and lets you know, hey, there might be a problem with the server, and you never had to look at a single dashboard.
And finally, we have the transBOARD. This one explored how a simple, familiar surface, like a whiteboard, could capture a physical action, like drawing, and just seamlessly beam those atoms of ink into the digital world of bits. So, the key thing to get here is that this wasn't just a bunch of cool sci-fi experiments from the 90s. This was a foundational blueprint for how we would eventually, all of us, come to interact with technology.
But you have to ask the question, right? It's been over a quarter century, a lifetime in the tech world. Do these ideas actually still resonate? Did this vision have a real impact?
Oh yeah, the answer is a massive, resounding yes. When you look at it, you realize the core concepts of tangible bits are absolutely everywhere today. Think about graspable objects like a Nintendo Switch controller, or ambient media like your smart bulb changing color when you get a message. And yeah, every single time you scan a QR code, you are coupling atoms and bits, exactly like they envisioned. But to really, truly understand the soul of their philosophy, the paper doesn't end with some futuristic gadget. It ends with this deeply personal story about a very, very old tool. Hiroshi Ishii tells this beautiful story about the abacus he had as a kid. To him, it wasn't just a calculator for doing math. He played with it, it made sounds like a musical instrument, and the rhythmic clicking of his mother using it for her work became this ambient sound that let him know when she was busy.
That one simple object, the abacus, perfectly and seamlessly blended the digital world of calculation with the physical world of touch and sound and play. It was an interface that was rich, that engaged all the senses, that had multiple layers of meaning.
And that, right there, illustrates their ultimate goal. It was never just about cramming computer chips into everyday objects. It was about making our interactions with information as rich and as human as our interactions with the world itself. And that leaves us with a really vital question to think about as we continue to design our future.